Welcome back to the Mastering Algorithms and Data Structures in PHP series. Today, we're diving into graph algorithms, breadth first search, BFS, depth first search, DFS, and Dijkstra's algorithm. These algorithms are essential for working with graphs, and by the end of this lesson, you'll understand how to implement each of them in PHP. Graph traversal algorithms are used to visit nodes in a graph in a specific order. Traversals help us find paths, search for elements, and solve problems involving relationships between nodes. Let's start with the two main traversal techniques, BFS and DFS. Breadth first search, BFS, is a traversal algorithm that explores nodes in a graph level by level, starting from a given node and visiting all neighbors before moving to the next level. BFS is often used for finding the shortest path in an unweighted graph. In this example, we start the BFS from vertex A, visiting all neighbors at each level before moving to the next. This makes BFS ideal for finding the shortest path in an unweighted graph. Depth first search, DFS, is another graph traversal algorithm which explores as far as possible along a branch before backtracking. DFS is used for tasks like detecting cycles in a graph, topological sorting, or path finding in mazes. In this example, we use a helper function dfsutil to perform the depth-first traversal recursively, starting from vertex A and exploring each branch as far as possible before backtracking. Next, we have Dijkstra's algorithm. It's used to find the shortest path between nodes in a weighted graph. This algorithm keeps track of the minimum distance from the starting node to every other node, making it ideal for path finding in navigation systems or network routing. In this implementation of Dijkstra's algorithm, we use a priority queue to keep track of the next node with the shortest distance. The result is the shortest path from the start node to every other node in the graph. Now, let's compare BFS, DFS, and Dijkstra's algorithm. BFS is ideal for finding the shortest paths in unweighted graphs. DFS is best suited for deep exploration of the graph, detecting cycles, and performing topological sorting. On the other hand, Dijkstra's algorithm is specifically designed to find the shortest path in weighted graphs with non-negative weights. These graph algorithms have a wide range of real-world applications. BFS is used for finding the shortest path in social networks, DFS for topological sorting in dependency graphs, and Dijkstra's algorithm for navigation systems like GPS, where it finds the shortest route between locations. To summarize, we covered breadth first search, BFS, depth first search, DFS, and Dijkstra's algorithm. Each of these algorithms serves different purposes when working with graphs, and understanding when and how to use them will help you tackle complex problems involving networks, paths, and relationships. Thanks for watching. If you enjoyed this video, please like, comment, and subscribe for more lessons. You can find the complete code for this lesson on GitHub. See you in the next video.